Friends and students, today we are going to learn about lattice translational vector. So before going to lattice translational vector, we should know about crystal structure. Crystal structure is a part of solid state physics. Now, crystal structure, these two words can be split up into crystal and structure. First of all, crystal. What is crystal? Crystal, in an universe, all the crystals exist in the form of solids, and solids contains or made up of atoms. Now, how these atoms are configured in a solid? So these atoms in the solids, atoms are arranged in a systematic manner or regular manner, means one after the other, or in periodical arrangement. Now, here I use the word periodical arrangement. What does it mean? It means in a certain interval of time, there is a repetition of certain unit or atom in a crystal, which is known as periodicity of that crystal. Periodicity of that crystal. So now crystal structure is made up of solids plus arrangement of atoms in the solid. So till now what we have gone through, crystal structure, which is a part of solid state physics. And then if we take a word crystal, in this universe all the crystals exist in the form of solids, and solids are made up of atoms. Now these atoms in the solids are arranged in a systematic manner or regular manner, which means one after the other, or in a periodical arrangement. Periodical arrangement is what? In a certain interval of time, or after certain interval of time, there is a repetition of certain units or atoms in a crystal is known as periodicity of the crystal. So, crystal structure basically is plus arrangement of atoms in the solids. Now, after getting these crystal structures, scientists have to study this structure. For this, they have gone for the instrumentation. So, after from some instrument, they have find out they have studied the crystal structure, and from there they have find out, they have made some theory. Now to explain this, now they have to explain this theory. For explanation of this theory, what they said, crystal structure is combinations of lattice and basis. So first we will take lattice. What is lattice? Lattice means cluster or collection. So this collection or cluster or collection either may be of points or atoms or directions or orientations. So, if here I'll draw these lattice points on this board, these are lattice points. Actually, in a crystal, lattice points exist in a 3-dimensional form. So, in this board, I can show you only in 2-dimensional form. So, if I take a x direction, the points in a lattice points, the distance from this point to this point, this point to this point, this point to this point, and this point to this point will be same. If I go along this direction, the distance between this point to this point, and this point to this point, and this point to this point, again it is same. So what does it mean? It means, so arrangement of these atoms or points are geometrically patterned or periodical arrangement is there. So, definition of lattice will be the regular arrangement of of points or atoms in 3D space. 3D space is called lattice. So now comes to bases. Bases. Here you see, in this lattice points, all the points are associated with, or any point is associated with either one or more than one point in a lattice. All the points are associated with any point of lattice is associated with either one point or more than one point or atom. For example, if I will take one point or one atom, let it be sodium. If I will take two atoms, that sodium chloride, positive, negative. So, if I represent sodium as O like this and chlorine as like this, so in this lattice point, how I can represent it? So these atoms or points, there should be or must be in the same orientation or a same direction in a lattice. For example, if I will take this direction, so this is sodium, this is chlorine, sodium, chlorine, sodium, chlorine, chlorine. Sodium, chlorine, sodium and chlorine should be in the same orientation. So, any point of lattice is associated with either one or more than one point or atom, but provided they must be in the same orientation or same direction. So, what I said, association in same orientation or direction. So, definition of basis will be any point of lattice, any point of lattice is associated with either one atom or more than one atom in the same orientation in a crystal. So, here I have already told you how it could be in the same direction, but provided the region or environment of this point or this point or this point or all the points in the lattice should be same as that of other point. So, the environment surrounding this point should be same. The environment surrounding at this point or at this point or at this point should be same. Now come to lattice translation vector. Lattice translational vector or translational lattice vector or translational vector. So, if I will draw here lattice points like this, like this. So, this is a point A. This point A should move to, let this be a point B, should move to this point B. By what? With the help of a translational vector. So, the translational vector, it helps to move point A on point B, provided or the condition is the area surrounding this point must be same area surrounding at point B. Let this will be a origin O. So, positional vector of point A will be like this. Let it be R vector, and positional vector of point B will be let it be r dash vector, and here we apply translational vector, or we operate translational vector t. Now we can find out the coordinates of this point A, B from origin. Now if we will apply triangular law, now it becomes a triangle. So if we will apply triangular law, OA vector plus AB vector is equal to OB vector. So OA is R vector, AB is T vector, and OB is R dash vector. Now we have to find the coordinates of point A. As we know that in a lattice, all the points are in a periodical arrangement. So the distance from this origin to this point, let it be A. This will be again the same A. And let the distance along this axis, it will be B. From this point to this point. And this point to this point, it will be again B. So coordinates of point A will be 2A and 2B. So R vector will be 2A vector plus 2B vector. Now we have to find out the translational vector t, how much it is. Now if I take distance between this point to this point, let it be A, and this point to this point, it will be again A. From this point to this point, the distance will be B, and this point to, now it is in the opposite direction, so this point to this point value will be minus B. So the coordinates of translation vectors will be 1A vector minus 1B vector. Now we have to find out the coordinates of vector of point B. Means R dash vector will be equal to A plus A plus A, that will be 3A vector will be 3A vector plus this along y-axis 1B vector. Let we will give this as equation 1. If we put all these values in equation 1, what we will get? R vector will be equal to 2A vector plus 2B vector plus 1A vector minus 1B vector will be equal to 3A vector plus 1B vector. So here 2A plus 1A, that will be equal to 3A vector plus 2B minus 1B, that will be equal to 1B vector. That will be same as that of position vector. What does it shows? It shows the environment at point A. At point A is same as that of at point B. Then only we can apply this translational vector to move this point A to point B. Here vector A, B are primitive vectors. These are called primitive vectors. So, in generalized form, in two-dimensional, we can write translational vector as n1 A vector plus n2 B vector, where n1 and n2 are integers. In 3D form, the generalized equation for translational vector will be n1 A vector plus n2 B vector plus n3 C vector, again where n1, n2, n3 are integral multiples whose value will be 1, 2, 3 like this. 1, n2, n3 will be 1, 2, 3. So this is what lattice translational vector.